So this is a question in which the line is in the profile plane. We have done one problem in which the line was lying in profile plane. So a line AB, 75 millimeter long, has one end A in VP, other end B is 15 mm above HP and 50 millimeter in front of VP. Draw the projections of the line when sum of its inclinations with the HP and VP is 90 degree. Means it is lying in a profile plane. Find the true angles with the reference plane and its traces. So we have already said that when theta plus phi equal to 90 degree, that means more than 90, theta plus phi greater than 90 is impossible case. The maximum case is theta plus phi is equal to 90 degree. So when it is the sum of theta and phi are 90, that means the particular line is lying in the profile plane. So that is this case. So line AB 75 millimeter long, that is the true length of the line is 75 millimeter, and one end is in VP, that is the top view of the A or small letter A will be in the XY line itself. Other end capital B is 15 millimeter above HP. So B dash is 15 millimeter above the XY line and 50 millimeter in front of VP, that is small letter B will be 50 millimeter below the XY line. Draw the projections of the line when sum of its inclinations with HP and VP is 90 degree. That is theta plus phi is 90 degree. We don't know what is the value of theta and what is phi. So since theta plus phi is 90 degree, we know that it is lying in the profile plane. And when a line is lying in the profile plane, the side view, that is the view in the profile plane, will give you, the side view is the view in the profile plane, and hence the when theta plus phi is 90 degree, the view in the profile plane, that is the side view, will give you the true length and as well as the true inclinations. So what we have to find out is find the true angles, the reference planes and its traces. So first we mark our dimensions in the base figure. So it is said that the end V is end A is in VP, so that means this distance should be equal to 0. And the other end B is 15 millimeter above HP, so this distance is 15, and 50 millimeter in front of VP, this distance is 50. And as I said, we have already mentioned that when HP plus theta plus phi is 90 degree, the front view and the top view will be lying in the same vertical line. So that is the projector through A and A dash, and the projector through B and B dash will be the same line. So let's see how it can be drawn. So first we draw the XY line. Then the first projector, it is the projector for A dash and A, as well as it will be the same projector as B dash and B. Since we need the side view, we need another vertical line. This line is actually the X1 Y1 line, that is whatever is towards the right of this particular line, that will give you the side view. X1 Y1. So now this is the point A. Since A is in VP, we can mark A as on XY line. Then this is the point B dash. Since B dash is 15 millimeter above XY line, and we know that since theta plus phi is 90 degree, we know that A and B dash and A dash, all the 4 points will be in the same vertical line. So that is how we can obtain the point B dash here, and point B, that is 50 millimeter below the XY line. So that is also opened up. Now what we do is we will find out the side view of the point B, that is B double dash. In order to get the side view of the point B, that is in order to get B double dash, what we do is we draw the locus of B dash, that is a horizontal line or a line which is parallel to the XY line through B dash. So this is the locus of B dash. And now what we do is we draw the side view in such a way that it is the distance of that particular point from the xy line is the distance that is say it is same as the distance that is the distance of its top view from the xy line. So in order to get this distance, that is this distance equal to this distance, that is what we need. So in order to get it, what we do is we project this distance to the x1 y1 line, that is drawing the locus of B. We project that particular distance. So now this distance, the distance AB is equal to this distance. Now from there we draw an arc of a circle. This arc of the circle is drawn with the center as this point. The center as the point of intersection of x1, y1 and xy. So with this point and with this radius, if you draw an arc, this length will also be same as this length. So this particular distance is now replicated here, this distance. Now from this point, from the point that we obtained right now, we draw a perpendicular line or a projector. So now this distance, this AB distance is now repeated here or replicated here. Now this distance is this point is B double dash, that is the side view of the point B. This we already have seen how it is being drawn. So now this is the point B double dash. Now we know that in the side view, since the theta plus phi is equal to 90 degree, we know that in the side view you will get the true length. So in order to get the true length, what we do is we, with the center as B dash and radius as 75 millimeter, we draw an arc on this x1 y1 line. And in the side view, this x1 y1 line represents the VP. In the side view, the x1 y1 line represents the VP. So in that particular line, we draw an arc. So and that particular distance, that particular point is the point of intersection of the arc with the x1 y1 is A double dash point, that is the side view of A. Now if we extend this A double dash B double dash distance to the xy line, then we will get the HT, the horizontal trace. This is the horizontal trace, the side view of the horizontal trace, not the actual horizontal trace. The actual horizontal trace will be in the top view. So this is the side view of the horizontal trace that we obtain. So then A double dash will be the side view of the vertical trace also, since that is the point which is lying in VP. So it is the vertical trace also. So A double dash will be the side view of the vertical trace also. So this is the side view of the vertical trace. Now what we have to do is we have to find out the point point A dash, or the front view of A dash. So from B dash, not to get B double dash, what we draw is we draw the locus of B dash. So the locus of B dash passes through B dash as well as B double dash. So if we draw the locus of A dash, which is a horizontal line through A double dash, it should pass through A dash also. So with this through this point A double dash, through the point A double dash, we draw the locus of A dash, which intersects with the projector through A dash, or projector through A, B as well as B dash. So that particular point is now A dash. So this is, now you can join A dash as well as B dash and A and B. Now in order to get the HT back in our original top view, in order to get it, what we do is we replicate this distance, the distance of the distance between the point of intersection of xy and x1 y1 and HT. So this distance we have to replicate here. So in order to do that, we draw an arc in the reverse direction from HT, such that that particular arc intersects with the x1 y1 line. And now from x1 y1 line, we draw the locus like this. The locus is drawn. Now this point that we obtained right now is the HT, the horizontal trace. So now VT is the point on the top, that is the A dash point, that is same as VT. HT is this point. Now A dash B dash is the front view and AB is the top view. And this line, this particular line in the side view represents the VP, and this line in the side view represents the HP. So as this line, the XY line represents HP in the front view and VP in the top view. Likewise, this vertical line represents VP in the side view, and this horizontal line, the XY line itself, represents the HP in the side view. So this is the front view and this is the top view, and we can join A dash and B dash in order to get the final front view, and A and B in order to get the final top view. So this line is the side view, and the length of the side view will be the true length, that is 75 millimeter. Now these two angles, the top angle, the angle between VP or X1, Y1 and the true length line is phi, the true inclination with the VP, and the angle between the true length line, that is the A double dash, B double dash line and XY line, that is theta. So that's it. Now you have to write all the values, that is the true length that we already have in the question paper itself, and the theta and phi that you have to find out, alpha and beta, that is both alpha and beta are 90 degrees in this case. So let me explain it once more, or let me show it once more. First our XY line, then the projector, then the distance between this projector and this X1, Y1 line, that can be any distance. It cannot be too, it need not be too close as well as not be too far. A 3 centimeter distance is enough. 3 to 5 centimeter distance is enough in between the projector and the X1, Y1 line. And then the point A is marked, and point B dash is marked, point B is marked. Now we obtain the side view of point B, that is B double dash. Now with the B double dash and 75 millimeters radius, we draw an arc on X1, Y1 line, and we extend the line, the A double dash, B double dash line in the opposite direction towards XY line, so that we get the HT, the horizontal trace. So this point is A double dash, and that same point is VT also. Now from A double dash, we draw the locus of A dash in order to get A dash. This point is A dash. And the same as VT. VT and A dash is the same. Now from HT, we draw the arc, and in order to get the horizontal trace in the top view. That's it. You don't have to write this HP, VP, front view, top view, true length line, etc., etc. Those are given for your understanding. A dash, B dash, then AB. This is the side view, that is the true length. Then the true inclinations with HP and VP are given. So then the true length, theta, phi, alpha and beta are written in the box as we mentioned. Okay. I think I don't have to draw it in the open board. Do I need to draw it in open board?
Sir, could you just draw it in open mode also?
Okay. So this distance is 0, this is 50, this is 50, and the true length is 75. Then theta plus phi is 90 degree. That is the conditions that are given. Now the scale. XY line. Now this is our x1 y1 line. Y1 line. Now what we need is we need the projector. This is the projector for A dash as well as A dash, B dash, etc. etc. Now in this one we have to mark the distances. Mm, 15 millimeter. Here it is 50. That's it. Going to B dash. Going to B. Now we need to draw some line. Yes, it is B. From this point we draw vertical line. This point is B double dash. This point will be. Now with this point as center and 7.5 centimeter, that is 75 millimeters radius, that is the true length as radius. We draw an arc here. Now this point is point A double dash. If we join A double dash with B double dash and extend the line, point of intersection of this line point is VT. Sorry, XT. This is point XT, and here is point VT. Point VT. Now from this point draw a horizontal line. So that it intersects with the now this point is point A. A dash, not A, it is A dash. Now what we have to do is we have to join A dash with the B dash. With the B double dash. B double dash. So this is the drawing, and this angle. This angle is phi, true inclination with the VP. And this angle is true inclination with the HP, that is theta. Now what we have to do is we have to find the HT also. VT is already there. This is point A as well as VT. See, you have to rotate it back. And from this point, draw a horizontal line. So this is the point HT. Point HT. And that's it. So this line is not existing. This line is not there. So this is the drawing. I hope you understood. Now you have to mark the dimensions of the dimensions of b dash, dimension of b, and true length. Nothing else is required because no other values are given here. The only thing is you have to create that particular box in which the true length alpha, beta, theta, and phi are given. Okay. Let's move on to the next exercise.